Hey everybody, so in this video we're going to be talking about finding domain of rational functions. So a rational function just means a function that has x in the denominator of a fraction, right? So like for example, this one is not a rational function, because x is on the top, it's in the numerator. So this one would just actually be a linear function. So there's no problems with domain, x can be whatever you want. Now the second one, g of x, notice that x is in the denominator of a function. This one is a rational function. Now what that means is we're actually going to have a problem with domain in this function, right? Because if you remember, in math, you can't divide by 0, all right? Which means x equals 0 is not something that we can put into this function. Because if we put x equals 0 into there, then that means we're dividing by 0, which we can't do. Which that means x equals 0 is not in the domain of g of x. It means we can put in any other x value we want, just not x equals 0. Alright, let's see what that looks like in practice. So number 11. So if we're going to try to find the domain of this, then again, we need to pay attention to the denominator of the function. We don't really care what's on top. We just care about what's on bottom, right? Because we want to make sure that that's not 0. So if we want to make sure that that's not 0, then we can just set w plus 3, which is that bottom part, and we want that to not equal 0. Right? Don't be scared about that does not equal sign. You can still do the same things as if it were a normal equal, so we're still going to solve it normally. We would just subtract 3 from both sides, which means w equals -3. Or sorry, does not equal -3. Alright, so what that means is w can be anything except -3. Alright, now we want to write our answers in interval notation. So how do we do that? Well, let's start off with just a number line. So if we have -3, say right here, and I'm going to be putting that just as a big hole right there, then if w can be anything else, it means it can be anything over here, and it can be anything on the right. It just can't be -3. So we're just going to write these two parts separately. So for the first part, that's -infinity all the way up to -3 with a parentheses because we don't want -3. Alright, union, the second part would be -3 to positive infinity. And that would be our answer. Alright, number 12. So again, we're just going to look at the bottom of this fraction. So we got 3m minus 9 can't equal 0. So we're going to add 9 to both sides. Get 3m equals 9. Then we can divide both sides by 3. Get m equals 3. Alright, now if m can't equal 3, then what that means is we're going to Draw our number line again. We have 3 right there. It can be anything to the left of it and anything to the right of it. So the left part would be negative infinity to 3, again with parentheses. Unioned, the right part would be 3 to infinity. All right, number 13. So again, we start off by just looking at the denominator. So we have k squared plus that should be 2k, not 2x, plus 2k minus 15, that can't equal 0. Alright, so what do we do for this one? Well, this one's quadratic, and if this one's quadratic, that means we're going to try to solve this by factoring. Alright, so if you remember split B, we have AC and B. So AC is negative 15, B is 2. So we need factors of negative 15 that add up to 2. So if we had negative 3 and positive 5, that would add up to 2 and multiply to negative 15. So that's what we're going to split B into. So we got k squared minus 3k plus 5k minus 15 does not equal 0. Then we do our grouping. So for the first group, the GCF is just k. So we have k times k minus 3. The second group, the GCF would be 5. So we have plus 5 times k minus 3. The insides match. As long as the insides match, we have k minus 3, k plus 5 can't equal 0. Alright, now once we're here, we set both of these equal to 0 individually. Alright, so we have k minus 3 and k plus 5, and we set both of those not equal to 0. And then solve those little miniature equations, which in this case is going to give us k equals 3 and k equals negative 5. And then we can go ahead and make our number line. So this time there's actually 2 different things we need to put on our number line. We have negative 5 and we have 3. So it just can't be those 2 specific numbers. So it can be anything over here to the left, anything in between, and anything to the right of 3. It just can't be those 2 specific numbers. Alright, so this time we have 3 different sections that we're going to need to write in interval notation. So that first section would be negative infinity to negative 5. Again, make sure that you are using parentheses for all of these. Unioned, the middle section goes from negative 5 to positive 3. Unioned with the last section that goes from 3 to infinity. Alright, so all of these are essentially just taking the denominator, setting it not equal to 0, solving using the methods that we've already learned, and just at the end, put it on a number line and get the spaces in between them. And that is it for domain of rational functions.